Okay, so on this one, you know that it's going to be a decay formula. Okay, they're telling you that it's 87% right here. If they tell you a percentage, that's already going to be what this is. So you're going to say 830 times 0.87 raised to the t power, right? And then you're going to plug in 2 years for this one. So this is going to be 830 times 0.87 raised to the second year. Okay, and when you plug that into your calculator, you're going to get 628.23. 628.23. Okay, and then they want us to know, or they want to find out, what is the value of the stereo if it's going to be half the original value. Okay, so first we got to figure out how much is half of 830. Okay, so I'm going to go into my calculator. I'm going to say 830 divided by 2. And that's going to give me 415, right? 415 equals 830 times 0.87 raised to the t power. Now, you can sit there and you can try to plug things in, or you can use the fact that you know how to do logs. Okay? So the first thing you're going to do in order to solve for t is you're going to divide by 830 on both sides. And that's going to give you 1/2 equals 0.87 raised to the t power. Then you're going to take this, you're going to put it into log form. So you're going to start your base, go to the outside, and finish out your exponent. So this is going to be log of 0.87 of 1/2 or 0.5 equals t. Sorry, that's all bunched. Okay?
I have a question.
Yep.
Where did the 415 come from?
Somebody just asked a really good question. They said, where did that 415 come from? They took 830 and divided it by 2 because it says half the original value. Okay? So if I put this into my calculator, I'm going to say log of 1/2 divided by log of 0.87 close parentheses. Make sure that you use your parentheses. And that's going to be t equals 4.97 years. So in about 5 years, it's going to be half the cost, right? Okay. Questions over this? To Beanie Babies. These things are like a hot craze, y'all. Thank you. Like literally, I had like a whole bag of them. There was such a demand for these critters, skyrocketed in value. Katie bought a Beanie Baby for $10. The stuffed animal's value increased at a rate of 7% per year. How long did it take for Katie to double her original investment? Okay. Huh? Yes,
So
it's
isn't
correct.
it 10 parentheses of 0.07 to the t?
So if we put 0.07, that would be a decay, right?
0.7.
That would be 70%. Interim review. Okay?
It's 10%.
So if we did it this way, wouldn't this be a decay though?
Yeah.
Right. So we need it to be over 1, right? So that's going to be 1.07 raised to the t. That's why this whole 7% and rates are a little bit difficult. You kind of have to play with the numbers to figure out, do you add a 1 in front of it or do you subtract a 1? So you kind of want to play around with it because sometimes the wording of this is a little tricky. So how long did it take for her to double her investment? So we're going to take 20 because that would be double of 10, right? And set it equal to our equation. And then we're going to solve for t. So we would divide by 10 on both sides. And that would give me 2 equals 1.07 raised to the t power. I'm going to put this into log form. So I'm going to start at my base, go to the outside, finish out my exponent. Equals t. And I would put that into my calculator. I would get log of 2, close parentheses, divided by log of 1.07. And it would take her 10 years. 10 years to double her investment. Okay? If the value is compounded continuously, how long did it take for the value to triple? Okay? So if it was compounded continuously, that would be this function, or this equation. Okay? So you're going to take your initial value, which is 10, e raised to your rate that you had, so 0.07, raised to the t. So we want it to triple. So that means that we're going to multiply it times 3 for her initial cost. So her initial cost was $10, right?
Yeah.
So to triple it would be 30. And now we're going to see how long it takes her. So we're going to divide by 10 on both sides. That would give me 3 equals e to the 0.07 t. Now, in order to get rid of that e, we're going to take the ln of both sides. So we're going to say ln of 3 equals 0.07 t. We're going to divide by 0.07 on both sides. And if we plug this into our calculator, we're going to get t equals 15.69 years. Account paying an interest of 3.2% compounded continuously. How much would Elijah need to invest to the nearest $10 for the value of the account to reach 8,300 in 5 years? So, first things first, it says compounded continuously, so that means I'm going to use this formula.
Okay, so what is
Okay,
it?
so we don't know what our initial cost is because that's what we're trying to find, right? Okay, but they do tell us what our final cost is, and that's going to be that 8,300. So we're going to take this equation and set it equal to 8,300.
Hold on for a second. What does P stand for?
P is your initial value.
Okay, and
E is a number. E is that 2.71. It's kind of like pi. You know how pi is like 3.14? It's the same kind of concept. Okay? What? E? 2.718. I mean, it has numbers after that, but that's rounded. Okay?
You said 2.718.
Yep, on the board. Okay, so then what you're going to do is plug in R. R is going to be that 3.2%. If I change it to a decimal, that's how I get 0.032. Now, they want us to solve for when it's 5 years. So I'm going to take 5 and I'm going to plug it in for this t right here. Okay, so this is going to be 8,300 equals PE to the 0.032 times 5. Okay. Now we're going to use logs in order to help us solve for P. So, first thing we want to do, actually, we don't necessarily have to. We can actually just evaluate this. So, if I go into my calculator and I type e to the 0.032 times 5 into my calculator, this is what it's going to look like. 0.032 times 5. It's going to give me this number, at 1.17. Try not to round until the very end, though. So you're going to take 8,300, and you're going to divide by this. So that's going to be, I'm just going to retype second ln 0.032 times 5. When I hit enter, I'm going to have P equals 7,072.79. So that means that I have to invest at least $7,000 in order to make 8,300 or have 8,300 in 5 years. It does say round to the nearest $10, so technically this would be 7,070. That would be the nearest $10. Last one. Okay, so we're going to actually evaluate this. That's what AKS 52 is. These are going to be on your interim. Like I'm telling you right now, it's going to happen. So you've got to know how to do this. So in order to evaluate this, since it's already in logs, we're going to put this in exponential form. So you're going to start at your base, go to your outside, and finish here. So you're going to have 5 to the second power equals x minus 3. If you had no idea how to do that, you need to go back and watch all my videos on logs, okay? Going from logs to exponential. So 5 to the second power is going to give me 25. And if I solve for x, that means I'm going to add 3 on both sides. X is going to be equal to 28. If you're ever unsure whether or not you did it right, take 28 and plug it back into this. Log of base 5 of 28 minus 3, does that equal 2? Well, if I put log of 25 divided by log of 5 in my calculator, I'm going to get 2. So it works. All right, this one's a little bit more challenging just because it has a quadratic, and I wouldn't put it past the county to put that on the interim. So with that being said, what you're going to do first is I would evaluate this mess, okay? So I would go into my calculator, and I would be like, all right, log of 15 divided by log of 2. And that's going to give me this decimal over here. So I already know that this is going to have a decimal type answer. But you're going to put this into exponential form, okay? So you're going to take the base, go to the outside, and finish here. So I've got 2 raised to the log of 15 divided by log of 2. And we're going to set that equal to x squared plus 2x. So I'm going to evaluate what I have over here on the left. So that's going to be 2 raised to the parentheses log of 15 divided by log of 2. When I hit enter, look what I get. It's a whole number. That makes my life a little bit easier, right? Hopefully, maybe just a little bit. Okay, so now you're going to move that 15 to the other side by subtracting it. And you're going to get x squared plus 2x minus 15. And now I'm going to factor. So I'm going to do a times c, which is going to be negative 15. And b is going to be 2. So what 2 numbers will make that happen? 5 and negative 3. So x plus 5 and x plus or minus negative 3. Or minus 3. Sorry. Okay. One thing that I got to make sure that I always check when I solve for these kind of problems is I can't have a negative value inside of this log. Otherwise, it's going to give me an undefined answer. Okay? So you got to make sure you check and make sure it works. So if I plug 3 in, that's going to give me a positive number. So that one works. If I plug negative 5 in, I'm still going to get a positive number because negative 5 squared is 25. 2 times negative 5 is negative 10, but 25 minus 10 is going to give me 15. Okay? You should get the same thing on both sides when you check. Last one. Ready? So, since both of these are the same logs on both sides, what you could do is really you could get rid of both side logs. Okay? And so you're left with this. And now this has just become a quadratic. So, you're going to subtract x from both sides and add 2 to both sides. When you do that, you're going to get x squared minus x plus 6. You're going to do a times c, which is going to give you 6. B is going to give you negative 1. What 2 numbers will make that happen? Negative 3 and 2. Actually, that's a whole lie. No, you can't get that. So, I would have to do the quadratic formula for this one. 2 and 3. There's not a negative here. So, what's going to happen is, if you plug this into the quadratic formula, you're going to get, and I'm going to pause this really quick. So, when you solve, this is what you would get. It would have no real solution. So just depending on how the question is actually worded, it would either be no real solution or this would actually be how you would write that out. And done.